And here in Thessaloniki, there's some flexible solar. Hi, so who are you?
Yes, hello, my name is Michael Hadzidis. I am from Aristotle University, from LTFN lab. Here is the facilities with the big pilot lines.
What is this?
This is a seed-to-seed pilot line. It has the ability to produce materials and devices like this one, the photovoltaics, unique in the world, that are flexibles and produce power, electrical power. So come with me to explain you what's going on.
And you can, it's like glove machines?
Yes, this is glove boxes we equipped with several of equipment and machines inside. Developing many of these here in Aristotle University. This side is the R&T part, the R&T seed-to-seed part. We can see here many of the materials. We preparate materials.
So you're testing different mixes and stuff?
Yes, that's right. We're testing different materials and mixes. Here is the small solar simulator, and we simulate and take all the electrical measurements as well.
All right, so it's like R&D area here, and there's...
And this is the middle scale area. Actually, we manipulate devices with the size of A4, 200 by 300 millimeters. Here there is a slow dye system, also plasma treatment, a printer, and also when we finished with the device, like this one, we coming here because you can observe there are larger, bigger devices and start the electrical characterization, and we found the efficiency and take some results as well.
All right, and it's important always to try to improve the efficiency, right?
Yes, day by day.
And this is, what is this?
This is a unique also system. It is a small roll-to-roll system. It is the first roll-to-roll system that built here in Aristotle University. It has a lot of R&T development. We take parts from all over the world and build this, and also support the larger roll-to-roll pilot line.
All right.
And now you come to the vacuum area. Actually, in this area, we can find the senior engineer, Giorgos Nomikos. Here are all the vacuum systems and some hybrid techniques with the gas transport techniques. We name it with his name. Okay, please. Giorgos? Yes. Yes, here Giorgos.
Hi.
We'll explain.
Hello. Hello.
Hi.
I'm George.
Hi. So what is this?
I will talk to you about this big system. This is called OVPD system. That means organic vapor phase deposition system. It is a technique that belongs to the general category of gas transport techniques. We could say that it is an upgrade version of vacuum thermal evaporation technique with some more advantages than vacuum thermal evaporation. What we do with this system, we can produce several applications like organic photovoltaics, organic thin-film transistors, or organic light emitting diodes. This is a high technology system. Let's mention one of the high level of technology, that is the robotic arm that is in the center of this system. It can move and place the substrate on each peripheral station for the production of a specific layer, organic or inorganic. Let me show you one of our substrates that we can produce. This is an organic photovoltaic, a specific pattern that we use.
So what is the materials here?
The materials here are both organic and inorganic. The organic one is the green one, you can see, and the white and silver one is the metal, the inorganic materials. That is the final step of our production.
What is the advantage of doing organics?
The advantage of doing organics are many. Let's say the low cost of these materials in comparison with silicon. Let's say that sometimes it is easier to produce such a device with organic materials than inorganic. But the main advantage of this technique and I want to say this, is the high level of homogeneity of produced layers that makes it suitable and maybe the best technique in the world for the production of organic light emitting diodes. This huge system, we could say that it was built in 2016 in the frames of European projects, the main core of this system, and from this time many specific peripheral tools have been integrated onto the system, some of which are very powerful tools for the user, like the real-time optical tools that give the user the opportunity and the ability to control and fix or correct something during the production. This is very, very important, especially in production level.
So there's many different areas of this machine.
Yes, yes.
And like, for example, this is different from that and this.
We basically start from this glove box where we prepare our substrates. From here,
Yeah.
we introduce our substrates inside the hybrid load lock, where the robotic arm then do the other job. We then control the system via computer and specific software.
So it goes to over there.
Over there, yes. Over there, this is the door. We open the door, we just load some substrates and some masks, and all the other job is controlled by the user via a software. And the robotic arm makes the other moves, and after each deposition, after each layer, the robotic has the job to take the sample from this station and move it to the next station for the next layer.
So it's moving around.
Yes.
It's moving through different machines. And
Yes.
what are the potential things you can do? Just a few things, or a lot of things are possible here?
A lot of things are possible, but for now we have focused on the production of organic photovoltaics and organic light emitting diodes in dimensions of 20 by 20 centimeters. If you see all this system, this is like a big room.
So this size.
This size. If we wanted to have a bigger size of this, let's say next generation, let's say half a meter to half a meter, imagine that this system would cover 2 or 3 huge rooms space.
Can you explain some of the other processes that are happening? Big machines that do different things, right?
Yes, big machines that do different things, different layers with a bit different techniques. All these techniques, as I told you, it belongs to the category of gas transport techniques, and all these steps are done under rough or high vacuum.
Nice. And how many people are involved with this?
Basically, several people are working on this, and some of them are dedicated to specific stations for specific layers. Some of them are, let's say, general managers on this pilot line, and some other guys are the guys that are working on, let's say, only computers and software issues.
Nice. So you're part of the university, right?
Yes, that's right. We belong to the Aristotle University, to the physics department, and the sector of solid state. And we are senior engineers here in the Nanotechnology lab. And all this job, actually, the production, it's not only as you see the OLEDs or the OPVs, it's also the scientific part and the results of this equipment. It is very important because a huge of development and a huge of effort is for the equipment.
So the results that you get are relevant for the whole world.
Yes.
Everybody's interested to optimize this technology. It could potentially change the world if we have cheaper, better
right.
solar, right?
You can observe now the OLED TVs are already in the market. Some companies in the world sell OLED TVs and some other things like the first phones, the first mobiles, and also the OPVs. It is the next energy, let's say,
it could be a big part of the future Green New Deal of Europe if they accelerate deployment of green green.
Yes,
Green
yes,
technology.
we based to the green energy. It is free energy. It is clear. We are not produce so many wastes. It is necessary to be careful about all the scientific things. It is a new generation of industry actually, because it is necessary to involve very smart tools and some robotics. The combination of the traditional industry with the smart tools and the robotics, it is the future for the manipulation of these new materials and then the products of them.
And if you show results, and I guess you already show results, then potentially there could be growth in this. There could be more and more things happening.
Yes, we have results to the conference that happen every year, the Nanotechnology. Now happen to the Porto Palace. We present the new results, the new efficiency, the new achievements of the LTFN lab, and we are very happy all the world coming here to see our job, and almost 700, 800 people coming from all over the world.
So did you reach some new levels of efficiency or something like that?
Yes, yes.
Did you?
Okay,
What can you say?
the numbers of the efficiency, it is only for the presentations inside to the rooms inside to the conference.
Okay, so let's go and check those presentations.
That's right.
Thanks a lot.